All right. So this last topic before you start your assignment is on the idea of the surface area and volume of similar solids. We've already discussed similarity. That was in the congruence and similarity test that you did. If objects are similar, what can we say they are the same in terms of, yes? Yeah, actually, you're right. I need to add that. Same proportions, but that's not what I was intending with the notes. I was intending you to say the same shape. Right? The same shape, but different size, yeah? Which means that they're... Actually, that's a nice link up. Different size. And because they're the same shape and different size, they are in the same proportion. Okay, good. That wasn't intended, but it actually works out because everything that we said there is correct. So scale factor is the measure of how many times the dimensions of an object have been multiplied. So if I look at these two cubes below, what are the dimensions of the smaller cube? 2 by 2 by 2. What are the dimensions of the bigger cube? 4 by 4 by 4. What have I done with those dimensions? All dimensions have been something. Good. Multiplied by 2. So therefore, what is the scale factor? 2. So get that down if you need it. Nothing's blue yet. It's not vital because these aren't formula. It's just for me to explain to you what is scale factor. We could find the surface area of these objects. Okay? If I wanted to find the surface area of the small cube, what would the area of one of the squares be on the small cube? 2 by 2. And how many sides are there on a cube? 6. Well done. So 4 times by 6, the surface area is 24 square centimeters. And then based on today's work, this is a kind of rectangular prism. And the volume is length times width times height. So the volume is 8 cubic centimeters. I could do the same thing to find the surface area and volume of the large cube. Surface area is going to be 4 by 4. Then times that by 6. I don't know what 16 times by 6 is. 60. I think it's 96. And the volume is going to be 4 times 4 times 4. 4 times 4, 16. 40, 64. So you could do that, okay? But in your assignment that's coming up, I'm asking you to do this repeatedly up to a scale factor of 8. There's a reason for that. You need to draw a graph. I'm not asking you to repeat it for the sake of it. Do you agree that if I had to do that freaking 8 times, would that take a long time? Would that take even longer if I'm asking you to make up a complex looking shape, like with a head, with hands, cylinders for legs, etc., and you had to do that friggin' 8 times? No go. So that's why I decided that I'll teach you some year 11 stuff for a shortcut to do that. Because if you wanted to find, if we know 3D objects are similar, then we have a shortcut to find the surface area and volume of the objects as long as we know the scale factor. So these are the formula that you need down to avoid doing that repetitive stuff. The new surface area of something is going to be k squared times the old surface area. The new volume something is going to be k cubed times by the old volume. And in both of these cases, k is the scale factor. That's why I explained to you what scale factor is, so they can use it in this formula. Can you please get down that rectangle there? Then after that, my example, let's see if it works on the previous cubes. So get that rectangle there. So in both cases, the scale factor, how many times the dimensions have been multiplied? Can we see if that formula works? So that formula is still on the screen. You can get it down if you need. New surface area is equal to k squared times by the old surface area. So SA new equals k squared. Going from the small to the large cube, can someone remind me what the scale factor was? That small to 2, good. So new surface area is going to be 2 squared times by the old surface area, which was 24. What is 2 squared? 4 times 24. What is 4 times 24? 96. So we've confirmed that that formula works for surface area. Let's do it for volume. V equals nu equals scale factor of 2, but I'm cubing it this time, times by the volume which we had here was 8. 2 cubed is what? 2 times 2 times 2? 8. And then I'm timesing it by 8. What is 8 times 8? 64 cubic centimeters. Does that confirm that it works as well? So now it's not going to be so painful to do it for a set of 8. All right, I'll stop the video there. What I've